Hi everyone, welcome back to Technical Mathematics. In lecture 4, we will continue with matrices and determinants. We will discuss about minor of a matrix, cofactor matrix, adjoint of a matrix, and inverse of a matrix. We will also solve few previous year exam questions related to these topics. So let's begin our discussion with minor of a matrix. At first, we will consider a 2 by 2 case. Suppose we have a matrix A with elements A11, A12, A21 and A22. Minor of matrix A can be calculated by replacing each element with the corresponding minor value. Say here A11 is replaced with M11. M11 represents the minor of A11. A12 is replaced with M12, which is the minor value corresponding to A12. And similarly A21 and A22 are replaced with their corresponding minor values, that is M21 and M22. Now let's see how to calculate minor of A11, the first element in the matrix. To calculate minor value corresponding to A11, we have to omit row and column containing A11. Find the determinant of the matrix containing left out elements. Here we have only one left out element, that is A22. So find out determinant of the matrix containing A22. We will get the minor value corresponding to A11. So if you calculate determinant of the matrix containing A22 alone, you will get A22 itself. So minor of A11 is equal to A22. So replace A11 with A22. We will get the first element in the minor matrix. Okay, the same way calculate minor values corresponding to each element present in the matrix and replace each element with the corresponding minor values. We will get the minor matrix corresponding to the given matrix A. So here the minor of A will be equal to A22, A21, A12 and A11. Now let's see an example corresponding to 2 by 2 case. Let A equal to 5, 4, minus 3, 2. Then minor of A is equal to. So we may calculate minor of A by replacing each element with the corresponding minor value. So here the first element is 5. To calculate minor value corresponding to 5, we have to omit row 1 and column 1. Check the left out element. We have 2. So 2 will be the first minor value in the minor matrix. Okay, in the same fashion we may calculate the minor values corresponding to the remaining elements. The minor value corresponding to 4 will be minus 3. Omit row and column containing 4, then find out determinant of the matrix containing left out elements. So here we have only one element left out, that is minus 3. So when we find out determinant of the matrix containing minus 3, we will get it as minus 3 itself. Therefore minor of 4 will be equal to minus 3. So here we will have minus 3 in place of 4. Now the next element is minus 3. The minor corresponding to minus 3 will be 4. Replace minus 3 with 4, we will get the minor matrix element as 4 here. Now the minor corresponding to 2 will be 5. Just omit row and column containing 2. The left out element is 5. Find out the determinant of the matrix containing 5. We will get 5 itself. So replace 2 with 5. So this will be the minor corresponding to matrix A. Now let's see a 3 by 3 case. If we have a 3 by 3 matrix like this with 3 rows and 3 columns, the calculation of minors corresponding to each element follows the same procedure that we discussed in case of a 2 by 2 matrix. If we need to find out minor of A11, we have to omit row and column containing A11 and then we have to find out determinant of the elements which are left out. So here left out elements are A22, A23, A32 and A33. So find out determinant of the matrix containing these 4 elements, that will be nothing but M11, that is minor of A11. So minor of A11 will be equal to determinant of A22, A23, A32 and A33. So this way we may calculate minor values corresponding to each element present in the matrix, then replace the elements with corresponding minors, we will get minor of the matrix. So the procedure is same as that of 2 by 2 matrix itself. So let's see an example. Suppose we have a matrix A equal to 1, 2, minus 1, 2, 3, 0, 1, minus 1 and 4. Then what will be minor of A? So you may try this by yourself. Please pause the video and calculate minor of matrix A. Okay, now if you have the answer, you may check the answer. Here minor of A is equal to 12, 8, minus 5, 7, 5, minus 3, 3, 2, minus 1. You may see how the calculation is done. The minor value corresponding to the first element 1 will be calculated like this by omitting first row and first column. Left out elements are 3, 0, minus 1, 4. So calculate the value of determinant containing these 4 elements. We will get value of M11. So here we are getting it as 12. Likewise, calculate each minor values corresponding to the elements present in the matrix. We will get the minor of matrix A, and the answer is this one. Now let's see what is cofactor of a matrix. Signed minor is called a cofactor. So if we have a matrix A equal to 5, 4, minus 3, 2, then cofactor of A can be calculated by modifying the minor of A in terms of certain signs which has to be assigned to the elements present in the matrix. So here in minor of A we have 4 elements. We have to assign certain signs to these elements to get their cofactor values. So the cofactor of a particular element present in a matrix can be calculated like this. Cofactor of element Aij, that is the element present in ith row and jth column, will be equal to minus 1 raised to I plus j into minor of Aij, that is Mij. So to calculate cofactor of the given matrix, we have to calculate cofactor values corresponding to each element present in the matrix, and then we have to replace each element with the corresponding cofactor values. Then the resulting matrix will be the cofactor matrix of the given matrix. So here we have a matrix A with elements 5, 4, minus 3 and 2. We will try to find out cofactor of A based on this formula. So here the first element is 5. Okay, so cofactor of 5, cofactor of element 5 will be equal to minus 1 raised to 5 is present in first row and first column. So I value is 1, j value is also 1. So minus 1 raised to 1 plus 1 into the minor value of 5. The minor value of 5 is 2. So minus 1 raised to 1 plus 1 into 2. That will be the cofactor value corresponding to element 5. So that will be equal to minus 1 raised to 2, that is plus 1. So the cofactor of 5 will be plus 2. Okay, now cofactor corresponding to element 4, the second element is 4. So cofactor corresponding to element 4 will be equal to minus 1 raised to 4 is present in first row and second column. So therefore minus 1 raised to 1 plus 2 into the minor value of 4. The minor value of 4 is minus 3. So into minus 3. So this will be equal to minus 1 raised to 3, that will be minus 1 itself. So minus 1 into minus 3, that will be plus 3. So this will be the cofactor corresponding to element 4 present in matrix A. Now let's calculate cofactor value corresponding to minus 3. So cofactor of minus 3 will be equal to minus 1 raised to minus 3 is present in second row and first column. So 2 plus 1. that into the minor value. Minor value of minus 3 is 4. So minus 1 raised to 2 plus 1 into 4. That will be equal to minus 1 raised to 3. That is minus 1. Minus 1 into 4, we will get minus 4. So cofactor of element minus 3 will be equal to minus 4. Now let's calculate cofactor corresponding to element 2. That will be equal to minus 1 raised to element 2 is present in second row and second column. So minus 1 raised to 2 plus 2. So that into the minor value. Minor value corresponding to 2 is 5. So minus 1 raised to 2 plus 2 into 5. That will be equal to minus 1 raised to 4. That will be plus 1. 1 into 5. We will get it as 5. So cofactor of 2 is 5. So we have calculated cofactor values corresponding to each element present in matrix A. Now we may write down cofactor matrix. Cofactor of A, matrix A is equal to cofactor corresponding to 5 is 2. Cofactor corresponding to 4 is 3. Now cofactor corresponding to minus 3 is minus 4. And cofactor corresponding to 2 is plus 5. So 5 comes here. So this is the cofactor matrix corresponding to matrix A. Okay. So this way we may calculate cofactor corresponding to a matrix. Now let's try another problem. Let A equal to this matrix. Find cofactor of A. So you pause the video and try to solve this by yourself. Okay, now if you have solved the question, you may check your answer. Here the right answer is cofactor of A equal to 12 minus 8 minus 5 minus 7 5 3 3 minus 2 minus 1. So to get this answer, at first you have to calculate minor of A. Then wherever we have I plus j equal to an odd number, that has to be assigned a minus value. Okay, so here if you consider this minor matrix, here the first element is 12. Its I plus j value is 1 plus 1, that is 2. It's an even number. So the sign to be assigned is plus 1. So this will remain as 12 itself. Now this second element is 8. I plus j value is 1 plus 2, that is 3. So which is an odd number, therefore we have to assign a minus sign to 8. So the cofactor value corresponding to this 8 will be minus 8. Okay, so this way we have to assign signs to each element present in the minor matrix corresponding to matrix A. Then we will get cofactor matrix corresponding to A. So here answer is this one. Now let's move on to another question. Question number 1. The cofactor of the element 8 in the matrix given below is. So we have a 3 by 3 matrix here. We have to calculate the cofactor value corresponding to element 8. So you may try this by yourself. Please pause the video and try to solve this question. Okay, now you may check your answer. Here right answer is option C, minus 6. How to calculate cofactor of this element 8? We have to follow this procedure. First we have to calculate minor of element 8. Then we have to assign a sign based on the position of 8. We will get cofactor value corresponding to 8. So minor of 8 is obtained by omitting row and column containing 8. So if you omit row and column containing 8, we will have left out elements as 1, 3, 4 and 6. So find out determinant of the matrix containing those 4 elements. We will get it as minus 6. Now the cofactor of 8 will be nothing but signed value of minor. So that will be equal to minus 1 raised to I plus j. Here I value is 2, 8 is present in second row, and j value is also 2, 8 is present in second column. So minus 1 raised to 2 plus 2 into minus 6. So that will be minus 6 itself. because minus 1 raised to 4, that will be plus 1. So value of cofactor, we will get it as minus 6. Okay, now let's move on to the next topic, that is adjoint of a matrix. So adjoint of a matrix is nothing but transpose of cofactor matrix. So to calculate adjoint of a matrix, first you have to calculate cofactor of the matrix, then you have to take the transpose. So here we have a 2 by 2 matrix A given as 5, 4, minus 3, 2. The cofactor of matrix A is 2, 3, minus 4, 5. So adjoint of matrix A is equal to, it will be transpose of this one. So that will be having the first row as first column of this matrix, that is 2 minus 4, and the second row will be having the elements corresponding to second column of this matrix. So that is 3, 5. So this will be adjoint of the given matrix A. Okay. Now suppose we have a 3 by 3 matrix like this, A equal to this one. Then cofactor of A is this matrix. So adjoint of A will be equal to transpose of this cofactor matrix. So here the first row will have elements corresponding to first column of cofactor matrix. So 12, minus 7, 3. That will be the first row. Then second row will have elements corresponding to second column. So that will be minus 8, 5 and minus 2. And the third row will have elements corresponding to third column of cofactor matrix. Okay, so that will be minus 5, 3 and minus 1. So this will be the adjoint of A. Okay. So adjoint of a matrix is calculated by first calculating cofactor and then taking the transpose. Okay, now let's see one question related to adjoint of the matrix. If A is equal to 1, minus 1, 2, 3, then adjoint of A is equal to. So you may try this by yourself. Please pause the video and try to answer by yourself. Okay, now you may check your answer. Here the right answer is option B. How to obtain this answer? Steps are given here. First step is to calculate the minor of A. We will get it as 3, 2, minus 1, 1. Then we have to find out cofactor matrix. Cofactor of A, we will get it as 3, minus 2, 1 and 1. Then we have to take transpose of this matrix to get adjoint. Okay, so when you take transpose of this one, you will get the adjoint of A, and that will be 3, 1, minus 2, 1. Okay, now let's move on to next topic, that is inverse of a matrix. So for a matrix A, if determinant of A is not equal to 0, then A inverse exists, and A inverse will be equal to adjoint of A divided by determinant of A. So for all non-singular matrices, A inverse is defined. But if the matrix is a singular one, that is if determinant value of the given matrix is 0, then inverse is not defined. So for all non-singular matrices, that is for all matrices with determinant value not equal to 0, A inverse exists, and we can calculate A inverse using this formula. Okay, now there are two properties related to inverse of a matrix. The first property says A into A inverse is equal to A inverse into A, and that is equal to I. I is the identity matrix of the same order as that of A. So the product of a matrix and its inverse will be equal to identity matrix of the same order. So if A is a 3 by 3 matrix, then A into A inverse will be equal to an identity matrix of order 3. Okay, now the second property says A into B whole inverse will be equal to B inverse into A inverse. A and B should be square matrices. That is the condition to be satisfied. So now let's try to solve a problem. Find A inverse of the matrix A equal to 1, 2, minus 1, 1. So before starting the calculation, we have to check whether A inverse exists or not. So that we can Verify by finding out the determinant. Find out determinant of this matrix. If it is non-zero, then A inverse exists. So please pause the video and try to solve by yourself. Now let's see how to solve this problem. Here the first step is to calculate the determinant. If determinant is not equal to 0, then definitely A inverse exists. So here determinant value will be equal to 1 into 1 minus 2 into minus 1. So 1 into 1 minus 2 into minus 1. If we calculate this, we will get it as 3. So determinant of A is non-zero, therefore A inverse exists. Therefore, let's proceed to step number 2. Step number 2 is to calculate minor of the given matrix. So when we calculate minor of A, we will get it as 1, minus 1, 2 and 1. Okay. Now coming to step number 3, we have to calculate cofactor of A, that is signed version of this matrix. So we will get it as 1 plus 1 minus 2 and 1. Okay. Now step 4 is to calculate adjoint of A, that will be nothing but transpose of this cofactor matrix. So we will get adjoint of A equal to 1 minus 2, 1, 1. Now the last step is to calculate A inverse. A inverse is equal to adjoint of A divided by determinant of A, and we will get it as 1 by 3 minus 2 by 3, 1 by 3, 1 by 3. Okay. So this way we can calculate inverse of a given matrix. Okay, now let's see one question related to this topic. Inverse of the matrix. We have a matrix here, that is 1 minus 1, 1, 1. So you may try to solve this question by yourself. Please pause the video and try to solve this question. Okay, so I hope you have the answer with you. Here the right answer is option C. Okay, so now let's see another question, question number 4. Which of the following matrices is not invertible? So we have 4 matrices here. We have to find out which one of these matrices is not invertible. So you may pause the video and try by yourself. Okay, now if you have the answer with you, here the right answer is option C. So how to solve this problem? Here the question is to find the matrix which is not invertible. That means a matrix which do not have inverse. So if determinant of a matrix is equal to 0, then it is not invertible. That means it will not have an inverse. Inverse does not exist. So among these 4 matrices, you have to calculate, or you have to find out which one of these 4 is having a determinant value equal to 0. So here in option C, you can see a matrix where we will have determinant value equal to 0. Determinant of this matrix will be 2 into 3 minus 1 into 6. So 6 minus 6, that will be 0. So here the right answer is option C. Okay, so with this we are coming to end of lecture 4. In lecture 4 we discussed about minor, cofactor, adjoint and inverse of a matrix. And in lecture 5 we will see what is Cramer's rule. So for regular video updates, you may subscribe to our channel Vadhyar Online Academy on YouTube, and for study materials you may subscribe to our Telegram channel using this link. So thank you. See you in lecture 5.